And today I'm going to talk about requirements capture in the context of the first project I started working on with the team, which is called OpenScan. I think most of us are familiar with the excitement of starting a new RSE project, but also the uncertainty, because usually the project's requirements aren't exactly clear. And so our first task is almost always mapping out the course that the project will take. But this can be quite challenging because the research landscape isn't static. This is a visualization of the evolution of the Mississippi River with these different colored lines showing past courses of the rivers taken. And I think many research projects have similarly overwhelming and tangled histories with changing histories, requirements, and designs. And this is an expected and even natural part of working in research, but it does make navigating these types of projects more challenging. And that's why requirements capture is particularly essential for these projects. OpenScan is an example of such a complex project, and I'll use it to illustrate the process of requirements capture. This is a National Institute for Health and Care Research Innovation Observatory project, and their core mission is horizon scanning research. They try to identify medical advances to ensure that those innovations reach NHS patients. And the challenge, though, is that the main way of doing that is through clinical trial records, and there's no central repository of global clinical trials. Instead, different governments and different regulatory bodies have their own registries with their own formats, which makes collecting and analyzing this data quite challenging. OpenScan is designed to address this challenge. It uses web scrapers and APIs to collect and standardize clinical trial records from around the world. But it was no longer meeting the needs of the Innovation Observatory. Its software and infrastructure had become very complex, it was poorly documented, and its tech stack no longer aligned with the team's skill sets. And this was making it very difficult and time-consuming for the team to maintain, and it was taken away from time that they wanted to be spent on research. And this is why the Innovation Observatory reached out to the RSE team. And so we wanted to make sure we carefully captured the requirements of OpenScan's redesign to make sure we addressed these issues and also didn't exacerbate these ongoing challenges. So first off, we started off with an assessment stage. Instead of diving right in and making changes, we focused on clarifying requirements and evaluating proposed solutions for the first few months of the project. We used that time to have regular meetings with OpenScan's key developers and stakeholders. And we used information we gathered both to document the current state of the project, including the pain points the team was experiencing, and also to document planned work using strategies like user stories, requirement specifications, and work packages. And these documentation steps were crucial because writing things down forced us to be precise, and it helped reveal any gaps in our knowledge. And it also helped us define the scope and deliverables for the RSE work, which can be very challenging for projects of this scale. I'll illustrate this process using an example work package that I've been focused on, which is redesigning OpenScan's web scraper system. And this system is at the heart of OpenScan. It has several different web scrapers that collect clinical trials from different registries, pipelines that process these records, a database for storing them, and then the data is used for further analysis in the team or disseminated through OpenScan's front-end applications. And we're very fortunate to have a very involved team and collaborators in the Innovation Observatory, and they came to us with some ideas on how to improve this system. So the current system is written in a Java framework that the team finds quite difficult to use because it's complex and doesn't match their skill sets. And it lives on an AWS server that's used for both development and production. And their proposal was first off to switch to a Python implementation, which is a much more accessible language for the team, and also to switch to a serverless deployment. If you're not familiar with serverless, basically you can give code to AWS, say, run this for us, please, and AWS will handle all the infrastructure that's needed to run that code, which means that the Innovation Observatory will no longer need to manage this server, and also figure out how much computing resources they needed as the project changed in size. And finally, the team asked for help implementing better tools for collaborating together when developing this system. We started off by writing user stories to clarify the goals for this redesign, and these take the form of, as a particular user, I want to achieve a certain goal so I can get some sort of benefit. And the advantage of user stories is that they help abstract away from technical solutions. So instead of writing a goal such as I want to write web scrapers using Python, we would say something like I want to be able to easily train researchers to write web scrapers. And so we can then evaluate multiple possible solutions that can meet that goal instead of being pigeonholed into one technical solution from the outset. Now, we put ourselves in the shoes of the Innovation Observatory developers because they were going to be the main people working with this system. And one of the first goals that emerged was that they wanted to be able to easily add new web scrapers so that they could expand OpenSCAN and also develop similar projects and use as a template for those projects. So this really emphasized that this software is not going to be static. They also wanted to be able to collaborate together when working on web scrapers so that this system wasn't just the responsibility of one or two people. But at the same time, they wanted to make sure that they didn't step on each other's toes during the development process and accidentally break each other's pipelines. Now, you probably noticed that a lot of these stories revolve around development and collaboration. So we decided to take a closer look at the team's current development workflow. And it quickly became apparent why this was a pain point for the team. And that's because there's just one login for this AWS server where the system lives. So the team could only work on this server, one person at a time, and was either developing live on the server or manually pulling and pushing, making changes to the code. So this means that any changes are very difficult to deploy. There was poor and inconsistent version control. And also, the system as a whole is quite fragile because this is a production server, so any changes could break the entire system. So this process had revealed a key new requirement for OpenSCAN's redesign, and that was for easy-to-use, reproducible, and traceable workflows for developing web scrapers. Now, in some ways, moving to a serverless deployment helps address this issue because it removes the bottleneck of that single AWS server that you need to use for development. But in other ways, it actually exacerbates it, which is what we were trying to avoid. And that's because you now have to specify the serverless configuration for each piece of code that you deploy. Things like what Python version should you use, and how much memory does this code need to run. And the default way of doing that is with forms like this on AWS. So they're neither particularly easy to use, reproducible, nor traceable. Our solution was to add infrastructure as code as a key part of the system's redesign. And in particular, we decided to use AWS's framework called the Cloud Development Kit, which allows us to write infrastructure as code in Python. So it fits very nicely in with the Innovation Observatory's core skill set. So we can replace forms, like I showed in the previous slide, with a few simple lines of code like this that specify the settings for running the code. And what this approach will do is allow the Innovation Observatory to collaborate together using GitHub to develop the entire web scraper system, so both the web scraper code and the server's configurations. And they'll be version controlled, any changes are traceable, and it's fairly easy to deploy updates from either directly from GitHub or via command line to a test or production environment. And this will also facilitate other software engineering best practices, like having reusable components that can be used for further development. Now, this is just one example of how we clarified OpenSCAN's requirements. And as we continue working on this project, we're keeping those Uncover requirements at the forefront of the redesign to make sure that OpenSCAN becomes maintainable moving forward, and also that the work that the Innovation Observatory does is reproducible. This is my first RSE project, too, so taking away lessons for future projects, and those are what I want to emphasize today. The first is to dedicate time for requirements capture, even if they're already proposed solutions. If it's an existing project, it's also important to investigate the current state and pain points, and you should document requirements to formalize your thoughts and communicate with your team members, and when possible, plan for long-term needs to ensure your software is maintainable. So I'm just a small part of the OpenSCAN redesign team, so I'd also like to thank my RSE coworkers and collaborators at the Innovation Observatory, and thank you for your time. With that, I'll take any questions.
Okay, thank you very much. So there are some few questions coming in. One is, did you use any specific tools to collect and store all information gathered through the specific stages and possibly get it reviewed?
Yeah, so we started off using HackMD, which is kind of like a collaborative markdown editing software, but it does have a limited number of users for the free version, so we ended up moving to GitHub. So using the wiki there to store things like user stories and the work packages, and then also GitHub projects to have more of a live version of requirements using a Kanban board. So that's been quite useful because the team already uses GitHub, so they're able to participate and respond to that board and that wiki. But we also, during our regular meetings, would propose solutions and present, we think this could be a good solution for these reasons. These are the requirements that we think you need. Is this correct? And that was quite useful, just having that regular meeting.
Okay, thank you very much. The next question is, how much resources, that is to say people, time, were dedicated for the specification of the new system while maintaining the current software?
So there are about 2 people on the Innovation Observatory focused on maintaining the software alongside their other responsibilities, and 2 RSCs working about 50% each on this project. And like I said, we spent kind of the first few months focused on the redesign, and then we still are continuing to clarify requirements as we go, but we're now focused on actually implementing those changes. And the team has actually, as part of this process, decided to hire 2 new developers that will be focused just on this project, because I think they appreciate now the amount of time that's needed to maintain this type of software. So there will be 2 full-time software developers on it.
Brilliant, thanks. The next question, how do you deal with requirement? I think that's the same thing that has been said. So the next one is, how do you prioritize the requirements? How do you do the prioritization of the requirements?
Yeah, that was actually something that we could have done better from the start, where we started working on one part and then it turned out actually another part was more pressing. So I think it's largely communicating with your stakeholders about what needs to happen when and just getting an idea of the timelines. And we do have, so there's Chris Marshall is the head of data science and AI on the Innovation Observatory team, so he kind of serves as the product owner. So having one person also who has that big picture in mind is very helpful for defining priorities.
Brilliant. Thanks for that. So there's one more which has to deal with how did you determine the skill or knowledge level of the researchers, and how did you bridge any gaps in their knowledge?
Yeah, so that's part of what we incorporated into our work plans as well, that we know we're going to need time for training. And they do have quite a high level of knowledge going in, like the fact that there's been multiple transitions on this team where the people who originally built OpenScan have left, so the fact that they've been able to take on this complex software and infrastructure and maintain it has actually been evidence of how tech savvy they are. And so, yeah, I think they were actually teaching us in this case. But again, it's a lot about communication and figuring out what the pain points are and making sure we understand the current system. But there will be time for us to teach these different AWS services, for example, that we're implementing.
Brilliant. Thank you very much. Shall we give a round of applause for